Greetings from EMC. Today we're going to be talking about SQL Server and XtremIO. We're going to be talking about storage efficiency in a three-part series. This is part number 2. In a typical SQL Server environment, you'll have the production application, but you'll also have it replicated many times, sometimes to over-provisioned storage, where we'll run reports and analytics and trending. We'll also have it provisioned out to test and development environments. Sometimes a simple 2 terabyte database can consume as much as 50 terabytes of space. With SQL Server deployed on XtremIO, you'll notice here in our demonstration that we can provide test and dev environments and analytical environments with capacity utilization essentially for free. We're going to show you this on a test harness that we've deployed on VMware. It's a 3-server environment that's running a financial services application. In our example, this is basically a 12 terabyte database. You'll notice that we're going to be taking snapshots of this. Because of the way XtremIO implements metadata, these snapshots are going to come at 0 footprint, and there will be no performance implications because of these snapshots.
We're going to begin with 2 12 terabyte databases loaded onto the system that'll dedupe down to 13.2 terabytes.
We've taken a number of snapshots already. We're going to take 2 more 24 terabytes worth of snapshots. Take a look at this again in slow motion. Notice how it jumped from 59 to 71. This is the capacity that we have available to us. Notice here again, 34 terabytes of free space. Look at this, the percentage that we've used of the storage array is only 35%. Take a look at this number here, 14.9 terabytes. That's the actual capacity that we've deployed so far. And yet, because we've taken these snapshots, we have 71.7 terabytes that seems to be in use. Let's take some more snapshots. We'll take multiple databases at once. We highlight the databases we want to snap, we show which folder we want to place them into, we create them, and they're virtually available. So keep in mind, every time I take a snapshot, I get to deploy this out to another group of users in my environment. Test, dev, production, reporting, doesn't matter. Let's create some more snapshots. Place them into a folder. Each one of these snapshots is crash consistent. Now take a look at this. We had started with 59, and we went to 81, now we're at 108.
And look at the number that doesn't change here. 13.2 terabytes still used.
Look at the other number that doesn't change here. Performance still 165,000 IOs, 1.2 gigabytes per second bandwidth. So how does XtremIO do this? We have no space reservations. We don't bloat our metadata because we're using shared metadata. Our snapshots are efficient, and the reason is because of this concept called shared metadata. So when we take the first snapshot, put it into production, we can then take another snapshot and put it into production. Both versions of the data use the same metadata, and the deltas, the changes to those environments, are reflected in singular metadata. So we have no metadata bloat. Let's continue this example. Let's take some more snapshots. Now remember, we had 108 terabytes of virtual capacity in production. We'll take another 24 terabytes of snaps. Notice here, 108 becomes 132 terabytes of deployed capacity. It's as if we're just creating capacity out of nothing. And this is part of the magic of XtremIO and Flash and the way that we implement metadata. We'll continue this example. Take 24 more terabytes worth of snaps. It's just this easy. 132 terabytes becomes 156 terabytes. And you notice again, no change in performance. If you need more than 15 terabytes of storage, we simply scale out, and 15 becomes 60. Sub-millisecond response time, virtually unlimited capacity. Expect more from XtremIO and EMC. Check out the white paper.